Okay, so this question is working out the empirical formula of a chemical and proving that the molecular formula of a chemical is C11H14O2. So the first thing to say is that I have 1.56 grams of my chemical, and when I burn that I make 4.26 grams of carbon dioxide and 1.10 grams of water. The next thing to say is that I know that my chemical is an O8, so that tells me I've got an ester, so I know I've got this Cu group here. So I know I've also got some oxygens in the compound. I can work out the ratio of carbons to hydrogens to oxygens by working out the mass of carbon in the 4.26 grams of carbon dioxide, working out the mass of hydrogen in the 1.10 grams of water, and therefore the difference between those two and the total mass of 1.56 is my mass of oxygen. So the first thing I need to do is I have my general formula. So I look at what mass of substance I've got, so in the first case it's carbon dioxide. I times it by the RAM of the element I'm interested in this case it's carbon, and I divide it by the relative formula mass of that compound. In this case I can say RMM because carbon dioxide is a molecule. So plugging those numbers in, I get 4.26 as the mass of carbon dioxide. The RAM of carbon is 12, and the RMM of carbon dioxide is 44. And that gives me a mass of 1.16 grams. Hydrogen I'm going to do exactly the same. The only difference this time is I need to take account of the number of hydrogens in water. So I need to multiply my numerator answer by 2. So I've got 1.10 times by 1 times by 2 divided by 18, which gives me 0.122. Notice that each of my mass answers are to 3 sig figs, so my final answer I'm giving are to 3 sig figs. My mass of oxygen, therefore, is just the sum of those two masses subtracted away from my total mass of my compound. Total mass of my compound is 1.56, and I've got the sum of those two masses, which gives me 1.282. And that gives me a mass of 0.276 grams. Again, notice that I'm doing it to 3 significant figures. I'm keeping that constant. The next step in my answer, so I'm getting a mark for my mass of carbon and hydrogen, that's 1 mark. A mass, therefore, for my mass of oxygen, that's the 2nd mark. Third mark is I need to work out the number of moles in each case by dividing by mass by the relative atomic mass of each of the species. So 12 for carbon, 1 for hydrogen, and 16 for oxygen. So that's my 3rd mark. My 4th mark is by ratio, so divide by the smallest number. That gives me 5.5 to 7 to 1. I can't have half an atom in my molecular formula, so therefore I need to multiply the whole thing by 2, which gives me C11H14O2.